Good afternoon, everyone, and good morning if you are in Vancouver watching us. Thank you very much for joining us on our webinar. It's the first of 2021 for us, so welcome again. Today I have the chance to have with me my partner, Christopher Sicotte, who's operation manager at JSA Machinery. I will, on my part, discuss about cutting and prefab. And Christopher, what are you going to talk to us about?
Today, we're going to be talking about distance servicing, what we can do via internet.
Perfect. So without further ado, Christopher is going to leave the screen for a few seconds, and I will start on my part. All right. So if you have been watching our latest webinars, I kind of did the manufacturing process backward. Started with paint now and corner cleaners and welders. Now I'm going to cutting and fab. So here are the different options that you have with JSA Machinery. If you're looking at a smaller production, the first options for cutting are going to be either Gamma or Hydra saws. The difference between both of them would be that the Gamma is going to allow you to cut one piece at a time, and Hydra is going to be cutting two parts at a time. Mainly we are selling much more Gamma in the aluminum industry, either for full aluminum window or more towards the hybrid windows if you are fabricating such a window. If you want to use one of those saws, the biggest advantage you can use with them, it would be to be sending a full cutting list directly from your office to your manufacturing floor. If you are not doing that, there's also like a smaller option, if I should say, of just punching in numbers manually for every cut. Again, depending on the size of your fabrication process. And if you are, if you're willing to have the fastest saw on the market right now, and you're looking at preloading and cutting only, not touching fab just yet, Rotox has developed a high-speed saw that's capable of cutting somewhere around 800 squares a day, so at 1,600 cycles a day, so two parts at a time. Preloading station up to 4 bars, so you technically have 6 bars always in the machine. So that would be the fastest saw that you can get for the North American market window. So if you're working on standalone saws and you want to be adding some fab to your manufacturing floor, right now, most customers are still working with a lot of copy routers, punches, end mills, name it. There's a few options there that you can look at. The first option would be to have a standalone CNC. So you would be cutting CNC and then going to your welder. We're talking about two different machines that are available from us. You have the Junior CNC or the Phoenix CNC. Both machines are pretty similar. One of the Phoenix is a bigger bed, faster tool change, more options about connectivity with the machine than the Junior, where you're just going to be using a barcode. That's the only option for giving the information to the machine, but it comes at a much cheaper price. So if you're looking at doing sashes, you're going to be able to do a lot of the process of pre-location of hardware on it. If you're thinking about the snubbers, keepers, rails, pre-location, some of the drainage can be done on sashes, but again, it depends on the drawings. If we're capable of diving in with a drill bit. If you're looking at manufacturing frames, you can do the lock, you can do the operator holes, you can do snubbers, and we can also do pre-drilling of mullions on casement, hung and slide windows. There's also options if you're doing a tilt and turn type of window. those are other options that can be done. And if you're looking at a CNC to do your mullions, just think it as one station that would do both end mills, your operator, your lock hole, and we could do the multi lock position as well. So there's a bunch of options there. So it's kind of a one-stop after your cutting to add to your factory, avoiding a lot of manipulation from your employees down the line, and it's kind of a one-stop process at this point. If you want to kick it to the next level, there's one option with Rotox. We do have a high-speed saw that has a fab center integrated. So instead of cutting somewhere around 800 squares, we're going to be going down to 400. But all those fabs that I just discussed that would go on a CNC would all be done in that time. So we're catching up with a high-speed welder. If you're going back a few years, welder was going to give you somewhere around 225 to 250 squares in one day. But then came the high-speed welders. High-speed welders came out with the capability of doing 400 squares on an 8-hour shift. So giving those numbers, we challenged Rotox to come out with a saw that was capable of keeping up with one of those welders, so any of the machines would not be a bottleneck for the other one. So they actually did come out with it, and we're proud to announce that those are available now. One of the biggest question that we have is can we avoid punches? So there's many reasons why we can take away some punches and keep some punches on the line. So first thing first, if you're gonna go with the easy ones, if I do have an example here of a lock. So I do have a drill bit just to show you. So it's an easy access. You can do the whole fab without anything that comes interfere with your drill bit. So it's an easy process. So it can either be done on a CNC or saw with integrated fab center. So that really is not an issue. So if you're thinking about lock operator, those are very, very, very easy fabs that we can add to your process. Then comes the prepositioning of hardware. So if you're thinking about prepositioning keepers, snubbers, rails, and many other hardware that you would want to locate on your profiles, well, those are not things that you're actually doing right now for most of the manufacturers I visit, but those would be really killing some time down your line, or your assembly line, where employees would not have to measure themselves anymore. So if you're thinking about pre-locating those hardware on the line, on those machines, it's not really time consuming for saws or CNC. So it's a very good added value that you can put in your process. Two different ways to look at those. I do have a part here. I did color the two little dimples that are on there. Those are not actually holes. They have just been dimpled. So what we do is that we kind of just go in with the drill bit and punch a little hole on the part. The reason behind this is that some places, rather having auto feed screws that you have to have material to screw in, but those are much heavier, more harder for the employees to drill in. So a lot of companies now are taking away those kind of screws and putting just regular screws where they want the machine to drill all the way through the wall. So those can also be done. So time consuming, it would be just about the same. The only difference is that the drill bit would actually be running instead of just being straight and just punching a hole in on your wall. So keep in mind that, again, if you're capable of diving in directly to your part, those are not an issue to add to any process if you're talking about a CNC that's standalone or a Fab Center integrated on a saw. Where it gets a little bit tricky is when you're talking about drainage. A lot of customers are asking us, can you automate drainage? The answer to that is yes or no. It really depends on your profiles. So different ways to look at it. So if I do have this part here, you see this hole, sorry, all right, like this. So if I'm trying to go in with a drill bit, see that I'm gonna go against the weather strip here. So there's a way that we could plunge in at an angle and do this hole. But keep in mind that this hole would be much bigger if we're doing this, because you have to have the drill bit go through everything. So aesthetically, it might not be what you're looking for. Same thing with this hole here. This hole is gonna have the weather strip in the way, so we could be going in at an angle. But look at your profiles, and some of them you're gonna see that they are really inside walls for your drainage. So those are not gonna be able, you're not gonna be able to plunge in either straight or at an angle. So there's no way you're gonna be able to do them. So most of the time, you're gonna have 2 or 3 holes that are gonna become your drainage. So if there's no way to make all 3 or 2 or 3 or 4 of them in the process center, it doesn't make any sense to be adding those process to your machine, because anyway you're still gonna have to punch it, and your punch is probably gonna do all of those holes at the same time. So if you're gonna be doing it on a punch for one, just do all of them on the punch. The other question that I do have a lot is ventilation holes. So I took this one as an example. I'm gonna come closer. So if you're looking here, you're gonna see a little bevel that makes it hard for a drill bit to go in and not go sideways, because it's gonna hit this this wall. Or you could have an inside wall like the little cage that I have here that's gonna be hitting the drill bit as well. That's gonna make it go kind of sideways, and most of the time it's going to be breaking the tool. And so you want to avoid that. You don't want to be doing those on the machine if you're going to be having tool breakage all the time. The last thing to keep in mind about drilling, drainage, drilling, ventilation holes, or any different fabrication that you are doing on a punch right now, is that keep in mind that the diameters are probably going to be bigger when you're doing them with a drill bit, because what I see a lot on drawings is usually we see like 3 millimeters holes, 4 millimeters holes, 5 millimeters holes, but the minimum that we're going to allow to put on a machine would be at least 5, but the best scenario it would be 8 to have a strong drill bit. So it's going to make your holes bigger. So is that the question you're going to have to ask yourself, is that good aesthetically for the outcome of your window? So just keep that element in mind. And if you are not sure what can be done or not sure, well, we're there to help. And the best thing is not trying to put everything on a saw or on a fab center when you're capable of breaking down your operation, not creating any bottlenecks on your factory floor would be the best scenario. So sometimes people are thinking that, hey, I'm buying a new equipment, I want to go to the moon with it, I want it to do everything, but it's not always the best solution out there, even though cutting down on some of those fabs would not make the machine cheaper or anything. Just keep in mind that what you want to keep is a workflow. So please call us. We're going to be more than happy to help you out figuring out what the best outcome for you is. So I'm not sure if there's any questions on the chat right now.
Yes, there was one. In your last webinar, you discussed fabrication processing directly on the welding production line, and today you addressed the fab processing during the copy operation. Can you tell us more about the pros and cons of each outcomes?
Okay, so good question. There is a lot of options that we can now do on welders pass-through lines, so either on the cooling station or the corner cleaner. Those are very good options for you. It's the question behind it is really when are you doing your investment. So let's give you an example. You bought a saw last year, and you don't want to invest on any more fabs, not changing your saw, but you want to invest in a welder and corner cleaner, and we are capable of adding some tools to it to make it easier for you down the line. Well, that would be a great investment. Or if vice versa, you just bought a welder, you just bought a corner cleaner, you don't want to change those, but you want to invest into making the factory floor more efficient. So we're going to be adding more of those fabs on the saw or fab center in between saw and welder. So if you're thinking about, I have the best case scenario, the best scenario I can find. I don't have a budget. I don't have a floor plan to follow. I'm working from scratch. Well, the best case scenario would be trying again to have every machine work to their fullest potential and not making them bottlenecks. So I would see a little bit of manufacture done on the saw, a little bit done on the line, so every station is going at the same speed and helping your process that's going to come after your welding and cleaning process, making the assembly of those hardwares and assembly of those windows much easier for your employee. So that was the only question, so I'm gonna make a little pause here and have Christopher sit back with us, and we're gonna start with Christopher. All right, so we are back. We are now with Christopher, my partner in the business. Christopher is, as mentioned earlier, manager of operation. Christopher has agreed to come with me today and talk about remote service, so service from a distance. The conversation came actually from a customer that was talking to me about competitor marketing his capability of doing a remote service, and kind of challenging me on the fact that, do you guys have remote servicing? But we've been doing it for many years. So I decided to bring Christopher with me on this webinar, as most of you are from the English Canada, so coming from outside of Quebec, so it might be something that you're nervous about, making some investment with a company in Montreal when you're in Vancouver, Calgary, or Toronto. What's going to happen if I do need service? So here is Christopher. So Chris, when do we require remote service?
Hi, Martin. First off, thank you for having me. I'm happy to be here. To answer your question, when do we need service? We would typically need service, online service, at any given time, really. But key factors to having it is distance, really, and delay of response. So by having that online connection with the machines, we're going to save all that traveling time that a technician could have by going on the road to that customer that might be 4, 5, 6, 7 hours away. So we're going to be saving that time.
Yeah, and most of the time we're actually using that as a factor, but we're also servicing local customers,
of course,
with remote control, because even though you're half an hour away, well, half an hour there, half an hour back, it's still an hour that we're going to be having to charge to a customer for sometimes the things that are going to take about 5 seconds to fix because it's just a small issue, or by remotely connecting to a machine, we're going to see the issue right away and be able to fix it or have a plan to fix it. So it's not necessarily something that we're going to use for distance, but it sure is something that could be reassuring for some of you guys. All right, so Christopher, can you tell us what do you see when you're doing remote control on a customer's machine?
Sure. Essentially, what we're seeing on our screen, on our end, is the customer's screen of the machine. So we're going to be accessing all the information the operator is seeing on that machine, to the exception that we will be having access to certain apps on that computer with some passwords, of course, to access some of those key apps to control any input-outputs, motor monitoring, some drives, some, all those essential electrical panel components that we would need to physically see, but we could see them online, and we have access to all of that, so that greatly helps. Yeah, for sure.
All right. Do we have any cameras installed on machines?
On some machines, we do have cameras. A lot of people ask that question for cameras. Don't get me wrong, cameras are good to a certain extent. Normally, where the cameras are placed, they're placed at a certain position where we only see the part being processed. But most of the time, the problem you're having it's not really where the camera is pointing at. I mean, it's not pointing at the drive or the motor or a switch that might be faulty. You still have to connect to the input-output list to see where the problem is coming from. So you could only see certain things with camera. And, it just comes in handy to have all those other apps at our disposal.
So the best camera would always be the guy that we're going to be on the phone with, telling us do some tests and do some things. It also is a security option as well to maybe some people would think that if I don't see anyone in the machine with a camera, well, I'm free to make the machine move, but what the camera doesn't see, you might have an employee that's in the electrical panel of the machine, for an example, and things could be dangerous for him if we're actually going to be starting to move the machine. So camera, not always the best option. Is there a planned maintenance schedule on the machines?
Yeah, any machine we get, we could program maintenance schedules on them. So either if you want to have a maintenance schedule every month, every number of hours, or any amount of items being processed in it after 30 frames or 40, 50, 100, 200, you could program them to have a pop-up on the screen to just let your employee know to either contact us or contact the maintenance department to have them come and just do their regular routine on the machine.
All right, cool. Can we program at a distance? For example, if I'm thinking about a corner cleaner, customer has a new profile that comes in from his extruder and doesn't want to have you fly in for a job that takes about an hour.
Yeah, well, that's happened a few times. Yes, we can program at a distance. Nowadays, programming on those, let's say, the corner cleaners are much more precise than they used to be for older generation machines. So we essentially just need that CAD drawing, which is technically supposed to be on point. And with our the CNC program that we have here on screen, we're able to put the knife that we want to program into that frame to that specific corner or point, and it's going to physically clean it there on the frame. So we're not afraid to program at a distance like older generations where you had the picture of your profile and you had to put a point maybe 10, 20 millimeters higher so it actually cleans at the right spot. You don't have that anymore.
Right. Okay. Can you give us an example of when we remote service the customer?
Yeah. Sure. So we have a customer that was maybe between 4 to 5 hours away. He had a problem with his corner cleaner that anytime he would do a process on a cleaning cycle, the vertical axis would just stop, and he'd have a inverter error message that it's appearing on his computer screen. So we connected to that computer, and with the help of those apps that we have installed on those computers and all those machines, we were able to pinpoint, and I don't know if you could show the next slide. We're able to see that on that motor, there you go. At the bottom, we see all the you see the voltage, the amps. You got the RPM on there. That's all in live, so we could see what's going on there. We were able to pinpoint and see actually that the amps for that particular axis was a little higher, so it was demanding more force to the motor, which caused the drive to fall into fault in order, it's just protection wise. So we had a good idea that the problem was coming from that axis, and we asked the customer then, with that information being given, to check if there was anything in the way, PVC dust or chips, just anything could get stuck in that axis. Turns out that there was nothing stuck in there, but they found out that all the bearings and the ball screws were all super dry, and had been a while since they hadn't greased them properly. Okay. So they just ended up greasing everything, and problem solved. Everything started moving smoothly. They were pretty happy about that, because it took us maybe, let's say, 15 minutes to solve that problem. Whereas if we would have went there physically, it would have taken 4 to 5 hours to go, 4 to 5 hours to come back, plus that, let's say, 15 minutes over there
to figure out the problem.
Yeah. I mean, it's fun problems for us. It's easy for the technicians, but the customer doesn't like it.
No, for sure. And when you're thinking about anything that's intermittent problems that you kind of have to keep an eye on the machine all the time, and thinking that you're going to have to be at the customer until that error occurs again. Yep. Well, by remotely looking at the machine is losing a lot less time than that. So like for an example, we could have a customer even close or far saying that he's got a problem that comes in once in a while. Mm-hmm. Well, we're gonna have him call us at the moment it does the issue, so we can have a full screen of what's happening in the machine at that moment, and not being on the call and trying to run there as fast as possible and trying to figure it out. And sometimes we're gonna have our customers stop very smaller time than if we were gonna have to travel there at that point.
I want to keep the least production interruption as possible. Yep. That's the whole point of it.
Is there any other information that you can access?
Yeah, sure. If we take an example of, let's say, the corner cleaner again, on this screen we can see that's basically a log that we see everything on there. We see production, we see if there was changes made to a program in a corner cleaner for a certain tool. We see who does it, with which login actually.
Can you explain the different logins?
Sure.
In the machine?
You got your standard operator login, where you have access to basically pressing buttons to, let's say, clean or weld, depending on which machine you have. Just standard operation, nothing too crazy to start programming anything and risking to break something or damage a tool by changing something you're not supposed to.
Yep.
You have let's say a technician login, where you could have access to those programming functions. And you have a admin, let's say, which is the one we would have, to have access to the complete system of the machine and be able to access those apps also at the same time.
All right. So one of the things you don't want to do is give those technician access to your customer, to your employees that are working on the machine.
No,
we've had horror stories like that. Employees would change some data in the machine. And good thing is that we can know who did it. Yep. With all the data that sticks in the machine, but you don't want to be changing those all the time.
No. That's one of the things we look at almost first thing when we log on to the machine to see what happened, what caused that.
Was there any changes?
Was there any changes that caused that tool to break? So we go and see there, see when it was changed, on what profile, put it back to what it was, problem solved.
All right. So Christopher, are you able to see any production data?
We are, let's say for a welder, if you look at that protocol here that we have on screen, it's we see everything that has to do with that particular frame or sash that was welded. We could see it for the month, we could see it for the individual profile that was welded, or for the week, day, we could see pretty much everything. On this one here, you know the start time, the end time of that welding cycle. You can see the width, the height that you welded. You can see the batch number, the profile number, the cooling time it took, which temperature which plate was at, so you can know if, let's say, a plate is starting to get faulty and it's not at a correct temperature.
Yep.
And you see all of that on each head. Individually, it's there. You see the melt time it took, the time it took to melt, which I just said, compression time. You see the positioning time, the insertion time. Insertion time is important. You could see how much time it takes for your employee to put the part in and go and press the button.
So you can monitor bathroom breaks.
Pretty much.
Just knowing if it took 2 minutes every time you're loading profiles, and you have questions on why I'm not reaching my numbers, and that would be a good indicator.
Yeah, because on this one here, we see we have one that took 41.23 seconds to load the machine and press start. Normally it's about 10-15 seconds, let's say. So there was some, going around or taking it easy on that one. And a little lower down, we can see the cut size. You could actually see on every bar that you have placed in, let's say, a 4-head welder, if it was cut at the correct length, which is a good key feature to have on those Rotox welders. You could see if there's a fault or a problem on your welder, on your saw, and you'd be able to correct it with there.
So if you guys recall our last webinar where we talked about welders, I did talk about this process where you're measuring every single parts that are going into the machine. So this is that data that I was talking about. So first of all, the first reason why we're doing it is for the welder to actually get to his real size weld at the end, but it's information that is available for you in the machine that stays there. So let's say at the end of the day, you could look at those numbers and see that, hey, I've been cutting my parts short all day or long all day, or if you see any mistakes there that could be fixed easily on the saw, well, you might be actually throwing away some material for no reason, and things like that. So it's always good, very good information to have on this part.
Of course.
All right, so I don't see any questions. Thank you very much, Christopher, for joining us. Your first webinar.
Thanks for having me.
Congratulations.
Yeah, thank you.
It's not easy to face the camera. Thank you very much to all of you that were logged in. You're going to be able to find the video again on our YouTube channel if you want to take a look back at it. If you do have any questions for myself, or Christopher, please feel free to give us a call or send us an email. If you do have a suggestion for what should be our next subject or who should be my next guest, I'm a taker as well. So please give me a call on that. I'll be more than happy to discuss either your projects or our next talk. Thank you very much. We will keep you posted on our next webinars. Thank you.